Write a Python program to calculate and display the interest on a loan amount using the formula. Interest is equal to principal into rate of interest into time, the whole divided by 100. Test your code by using the given sample inputs. Verify your code by using the second sample input highlighted, which is given below. So sample input, principal amount is 20,000, rate of interest 5, and the duration is time is 10 months, let's say. And the expected output should be 10,000. And for the other variable, if it is 7,800, then rate of interest 7.7, 26 is the time, the duration, then we'll have to generate the interest. So remember, we have to submit the assignments exercises always. Yes. Let's look at the problem statement. Here it's very simple. They already have given the interest is equal to principal into rate of interest into time, the whole divided by 100. That's a equation is given here. We can easily proceed. So do not modify anything. We need to write code from here. Start writing your code from here. Populate the variable interest. So all we need to do is interest is equal to principal into rate of interest into time, the whole divided by 100. Yes, so let's put the whole divided by 100. So to check, we'll test with this value 20,000, 5, 10. So 20,000, 5, 10. So 10,000 is what we get. Yes. This is expected output. Now we'll have to verify this output. It will say it is incorrect. Why? Because we'll have to verify this output with these values: 7,800, 7.7, 26. 7,800, 7.7, and this is 26. Execute this, verify, you get correct solution, and then you submit it. You'll get the message your code has been submitted. Something like that. The next problem statement is write a pseudocode to find out if a given year is a leap year or not. Any year which is divisible by 4 and not by 100 or leap years. Otherwise, any year which is divisible by 400 is also a leap year. Use the drag and drop option provided to create the correct pseudocode. This page has system assisted problem solving. Interactions would come to your help if you wait at any step or if you make a mistake. We encourage you to try different logic variations. If I have understood the problem, let me start solving. You click on S, so it gives you only one. So that what we saw was in the past a pseudocode magnet. All the pseudocode magnets we have been saying, but now only one it starts. I think it encourages the interactive mode, right? Input year, that's our input we need to get. So they said if year is divisible by 4 and not by 100, so it is divisible by 4 equal to 0. Year modulus 100 not equal to 0. Then what do you say? You say it's a leap year. Yes, you say it's a leap year. Else if otherwise. Any year which is divisible by 400, right? That is also a leap year. Yes, it is a leap year. And the last part, if, else if, no, the last part else, right? If you wait for a while, it'll ask you questions. Like you understood this, or if you got stuck with something else, like that it'll give you a message. So if none of the cases are failed, what you have to do, we'll have to say it is not a leap year. Then end if, finished off. So yes, we'll move on. Write a pseudocode to check whether a given number is a palindrome. So it's simple, like you would have tested it for a string, now we're going to test it for a number. So here, input a number, while number not equal to 0, you'll have to find while number not equal to 0. It is here. Before that, you take the value of number, copy of the number, then yes, you can have a variable named as temp. You can take a copy of this because we are going to do modifications on number. Number not equal to 0, we'll have to take out remainder. So you get modulus, apply modulus operation, you get remainder. Reverse is equal to reverse into 10 plus remainder. It works this way. I want you to solve this. Please take a number like 1, 2, 3 or 1, 2, 1 and see what happens. You apply these formulas and see what happens. Right? In fact, I would like to explain this step by step if possible. Then number is equal to number divided by 10. So this will reverse. Then we can actually end while. Then you can check if temp equal to, temp has the actual number because you have divided the number. If you had 121, when you divided, number is equal to 121 divided by 10, it becomes 12. Then again you put it in the loop and see at the end it will be at 12. 12 by 10 it will become 1. So it changes. That is why you have taken a copy of number to temp. Now you check the updated value here in the reverse. Now you are going to check the actual number which is copied to temp and the reverse number. Temp equal to reverse. Then you say it is palindrome. Yes. You will say here is not a palindrome and you will have to end the if. So it says your answer is wrong. So one thing we forgot to do was we are using a variable named as reverse and it has to be initialized. So once you done with this and you get the answers like that. So this is a complete answer, right? You will like to work out an example. Let's say how this logic works. If you want to take a look at, so let's say R reverse, I said is equal to 0, right? The input number, let's say input number, I'm going to give 1 to 1. This is applicable for any example. Then you say temp is equal to num, which means what will happen at the end is temp will also have 1 to 1. Right? Now you say while num not equal to 0, which means 1 to 1 not equal to 0. Yes. So the condition is true. So what do you do? Now you're going to take out the remainder. So let's say remainder R is equal to, you have num modulus 10. Num modulus 10. This is the first iteration. Iteration 1. Iteration 1. So num modulus 10, which means the bracket I would like to say 1 to 1. If you do what do you get? You get 1. So that is R becomes 1. Now what you do? Reverse is equal to reverse into 10. So reverse was already having 0. 0 into 10 will become 0. Right? Then you say remainder. So in this step, what will happen is, so reverse is equal to reverse into 10 will become 0 plus 1. That's what you get. Right? Then it goes up, iteration 2. Then not just that, you also have done num is equal to num divided by 10. So which means 1 to 1 divided by 10 will become 12. So 12.1 literally it becomes 12. Now we'll move on to iteration 2. Iteration 2, second iteration. So while num not is equal to 0, the value of num is 12. 12 not equal to 0. Condition is true. Come down. You take a remainder. Remainder is equal to num by 10. So num by 10 is nothing but 12. With 12 num modulus 10. 12 modulus 10. So what it gets? The remainder R gets the value of 2. Right? then you say reverse is equal to reverse into 10. The value of reverse was 1. 0 plus 1 1. So 1 into 10 plus remainder. Value of remainder is 2. So it will give you 10 plus 2 12. Okay. Then num is equal to num divided by 10. So what will happen? 12 divided by 10 will become 1.2. It will get 1 if you get in a decimal integer. So let's move on to iteration 3. So iteration 3 says r is equal to remainder modulus 10. So 1 modulus 10. So 1 modulus 10, what do you get? You get 1. Right? Then reverse is equal to reverse has the last value reverse had was having 12. So 12 into 10 plus remainder. So remainder is 1, which we got it here. So this will give us 120 plus 1, which is equal to 121. Okay. Then num is equal to 1 divided by 10. So which will 0.1, it will result in 0. Then you go to iteration 4. What it says? So num not equal to 0, 0 not equal to 0, condition is false. So condition stops right there. So final results will be will have 121. Now you will compare. Okay, we'll compare. If revised is equal to temp, so what will happen? 121 equal to 121. So it is true. So what you will say? You will give a message saying palindrome. That's it. Write a pseudocode to find the sum of numbers divisible by 4. The pseudocode must allow the user to accept a number. Please read it carefully. The pseudocode must allow the user to accept a number and add it to the sum if it is divisible by 4. It should continue accepting numbers as long as the user wants to provide an input and should display the final sum. You can drag and drop the pseudocode magnets to the pseudocode steps boxes and create the appropriate pseudocode. So if you look at this, you understand. So there are several magnets. I have used most of them, and only 2 I found not non-usable. So the pseudocode must allow the user to accept a number and add it to the sum if it is divisible by 4. That is number 1 condition. Find the sum of numbers divisible by 4. It should continue accepting numbers as long as the user wants to provide. So which means I need to put it in a loop. It has to keep continuing. So for that I have set choice is equal to yes. Then because I'm starting, while starting we'll have to put it this way. While choice is equal to yes, choice is equal to yes, you're going to read a number and you're going to check if it is divisible by 4. If it is divisible by 4, then you're going to add it to the sum. So sum is a variable which we need to use. So that is the reason we have initialized above. Then you're going to end this. If it is divisible by 0, you will add it to the sum, otherwise you don't. Then you are asking a question, do you want to continue? If you'll have to input a choice. If it is yes, this will get continue, otherwise it will get terminated. Then finally you will display the sum. Yes. So this is another problem statement. A 3-digit number is said to be an Armstrong number if the sum of the third power of its individual digits is equal to the number itself. For example, 371 is an Armstrong number because if you perform right, third power for 3, third power for 7, third power for 1, all together will give you 371. Again, 407 is another example. You do cube 4 cube plus 0 cube plus 7 cube, you will get 407. So write a pseudocode to check whether given 3-digit number is an Armstrong number. Again, pseudocode magnets, again drag and drop. right? So let's look at the magnets available. So we're going to say while number not equal to 0, then you're going to take input number. Then again here you will have to perform sum. So we'll have to initialize sum is equal to 0. Then what is available? We'll have to take up remainder. Before you take up remainder, ensure you take a copy of this number, right? Yes, to temp, because you're going to do manipulations on number, variable number. So remainder, you will take a remainder. Then sum is equal to sum plus remainder cube, thrice. You multiply it, remainder into remainder into remainder. And what you will do? Number is equal to number divided by 1. It will keep doing. Then once you are done with this, you will have to end the while loop. Then you will check if temp equal to sum. You will say this is Armstrong number. This is Armstrong number. Else this is not an Armstrong number. You will have to end if. Let's see what happens. Such as your answer is wrong. So only change we need to do is you have taken a copy of number to temp even before reading the value for number. So you'll have to do this after the statement. If you do this, it should work. Yes. There's another interesting pseudocode. Write a pseudocode which helps the symbol O, right? The symbol is something like a robot to reach A. The symbol is here. It has to reach to this location E. Right? There are many ways to follow. Now we are going to do this. While start not equal to end, there are many. If path ahead available, then you say move forward. If left turn, else if left turn available, you will have to turn left. Simple. Then you'll have to end this if. Then if key found, unlock lock. Else if diffuser found, diffuse forms. End if. End what? Let's see what happens. Yes, you have reached the destination. Interesting, isn't it? So this is another simple pseudocode. Recreate the figure given the expected canvas. So we'll have to recreate this. 4 mountains, 3 sheep. So simple. 0 to 3 will help me to add 4 mountains. Add mountains. Yes. Then you'll have to end for. Then 3 sheep. So I'll take 0 to 2. Then it has got display daylight. So find out. Yes, display daylight. Such as you got the right answer. So there's another example. Expected canvas, the current canvas. So 1 mountain, 3 trees, moon and sheep, and there is snowfall. So yes, display moon, display snow, then you'll have to display the night sky, 1 sheep, add sheep. I think then all we have is, yes, 1 mountain we have, so add mountain, 3 trees, use a for loop, 0 to 2, three trees, yes, I'm sorry, add tree, info. Perfect. Write a program to create the following pattern. Before you start this, I request you to watch the video 5 turtle graphics to understand these things better. So let's see how it works. Run code, right? so it's not moving around, so it is commented, right? There's Alexa turtle, shape turtle, the color red. All these helps us to just create a turtle symbol. If you use blue, it gives us a blue color, right? Please refer the turtle graphics video to understand these things better. So what I'm going to do is I'm going to uncomment, then you may comment it here, so you'll understand these things better. If you do this, Alex circle, you have given a radius for the circle, so it draws the circle. And if you say forward, right, backward 50, it comes back. Let me, yeah, right, look at this, it comes backward. So if you say 50, it is so. To achieve this output, we should have at least the length at least 100. Then again you'll have to say forward, you should go at least 200, only then you'll go double the size, right? Backward and forward. Then you'll have to take left, right? So you'll have to say take left. Alex dot left, it has to turn left. So this is not required for now. So what I'm going to do is single line comment. And you say Alex dot left to turn. If you say 60, it does not turn 90 degree. Yeah, to turn it, let's change it to 90. Then you say Alex dot forward, let's say 100. Yes, so you'll have to say again Alex dot left 90, then so from here it was 100, so I want this to travel up to this place, so it should be 200, forward 200. So there's a comment line, it does not, it will ignore this line, so it does not execute this. So only thing is it has to turn left and travel another 100. Alex dot left 90, Alex dot forward 100. So only thing is the color, it is not the same, so you'll have to change this to red. We got this output. We need not to submit this problem, so all you need to do is just to run and see, experience how Turtle Graphics works. So the next exercise is, so you'll have to help the symbol to reach E, right? So again the same, while start not equal to end, you're going to say so if red key found, unlock red lock, else if blue key found, unlock blue lock, end if, then so you'll have to, it has to keep going. If right unavailable, then you'll have to turn right, end if, end while. So this move could be anywhere, you can place it here or somewhere else, it works fine. Turn right, there is a right available, so it takes right, then reach the destination. So the last problem statement, right, you'll have to segregate it very easily. GIT University offering degree courses to students has decided to provide scholarship based on the following details. So they have two divisions, arts and engineering. If for arts graduate, if they secured 90%, 90 and above, at least 90, so which means 90 and above, the scholarship is 50. Engineering is more than 80, which means it should be greater than 85. It should be at least 86. So if it's going to be a score, their score is an odd number, right? If say 87 or 93, then they get the scholarship of 5%. The engineering graduate, if it is divisible, if their score is divisible by let's say numbers like 49 or numbers like 70 or 77, it is divisible by 7, so they get this scholarship of 5%. So we'll have to do this for, there are 500 students available, you'll have to do this for 500 students. You'll have to read for every write a pseudocode to calculate and display the final fees to be paid by each student. You may accept the branch of study, you'll have to read as a course fee as the input, score and score fee as the input for each, and calculate the final fees to be paid by each student based on the formula given below. So scholarship amount is equal to course fee into scholarship percentage. Final fees is equal to course fee minus scholarship amount. Right? So look at the things. So we're going to do it for a 500 students. So we'll take 500. Right? We'll have to take input as a input branch, score and course fee. So there are two major divisions, arts and engineering. So we're going to work for arts now. So if they say 90, at least 90, so which means if score is greater than 90, then the scholarship is 50. Else no. So before I use else, if score is an odd number, then you give a scholarship is equal to 5. So they have told you very clearly, the student is eligible only for one scholarship percentage, even if the score conditions are valid for the given branch of study. In such cases, students are eligible for the highest scholarship applicable. So pseudocode magnets here by default follow this, because you give score 90 greater than 90, this is the maximum, 50% is the maximum. You check this, if this is true, he or she gets 50% scholarship. Otherwise it comes to if it is an odd number, he or she gets 5% scholarship. So highest is 90%, by default it works. So we'll have to end if. Then this arts part is over, then we'll have to do this for engineering. We'll have to do this in the same way. So we've done the same for engineering. Score is greater than 85, because at least 85, this minimum 85 they set, more than 85. So that's the reason we have used greater than symbol here, greater than or equal to at least 90. Right? And if it is divisible by 7, so that's the reason we used to model operation, the scholarship gets 50. So once you're done with this, you'll have to calculate the scholarship amount, then calculate final fee, then display the final fee. So remember, then that's it, we can actually end the for loop. But throughout this, we have used a variable named as score that needs to be initialized. Ensure you initialize this variable, scholarship, because we got score, course fee, branch of studies, everything as input, but scholarship was not initialized. We used the scholarship everywhere. So that's the answer. Take a look at it. Alright, we're done with the day 1 exercises, assignments. Now let's move on to day 2.